Today we're discussing material and preparation for section 3.2. So we want to get really good at simplifying radicals. I want to do a little more practice here with just some numbers. So focusing in on something like square root of 48, we want to think about, are there squares that we know of that go into 48? And the squares we know of are 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, and 5 squared, which is 25. And this list keeps going. And so those are just kind of some of the ones to have in mind. So when I look at 48, I think, well, 4 goes into 48, but also 16 goes into 48. So we can rewrite the square root of 48 as the square root of 16 times 3, which then we can break up the square root and do root 16 times root 3. And root 16, of course, is just 4. So we get 4 root 3. And that is how we simplify our squares. Now looking at 72, well, 72 is divisible by 9. So we could write root 72 root 9 times root 8. I like to just go ahead and break up the square root right away as we're breaking 72 into its factors 9 and 8. So I look at 9 and I go, oh, well, 9, the square root of 9 is just 3. And then I look at the square root of 8. Well, the square root of 8 is divisible by another square. So we're going to break that one down in an extra step. The square root of 8 we're going to write as the square root of 4 times the square root of 2, because 4 times 2 makes 8. So now I have 3 times the square root of 4, which is 2, times the root 2 that we're left with. And so this gives me 6 root 2. So sometimes we don't pick up the largest factor that goes into something like 72. So we could have picked up that 36 goes into 72, but it's okay if we didn't see it. We just might have to do simplification in a couple steps like we did here. Now we're going to look at simplifying the square root of 50. Well, naturally, 25 goes into 50. So we rewrite square root of 50 as the square root of 25 times the square root of 2. And of course, the square root of 25 becomes 5, and we're left with root 2. And that's it for simplifying radicals. Just get some more practice with these as you work on these worksheet questions. Another really helpful thing to practice is to know when you can factor out the greatest common factor of a quadratic. So, and specifically from its coefficients. So looking here, we see that we have a 3 in front of our biggest term, the x squared. And the other terms are also divisible by 3. So if I wanted to factor this completely, I would pull out a 3 like this. I get 3 times x squared plus, now I need to do 12 divided by 3, because I'm trying to pull a 3 out of each term. So this becomes 12 divided by 3, x, which of course is just 4x. But for note-keeping purposes, I'm writing out the extra steps here. Minus, and then we again do 15 divided by 3, the 3 we're pulling out, and close parentheses. And of course, this would get simplified to 3 parentheses x squared plus 4x minus 5. And that's how we factor a 3 out of each of our terms. We're going to do that again down here. We have a 4 in front of our x squared, and then the other term is an 8, which is divisible by 4. So if I factor out a 4, I have 4 parentheses x squared plus, and then I'm not going to write out the extra fraction step in this time. So I'm doing 8 divided by 4, which is 2, and I still have an x. But notice now, each of my terms have an x. So they have another factor in common. And this is the case when I can actually pull an x to the front from each of my terms. So I not only pull a 4 to the front, but I can actually pull an x from each of these. So I have 4x, and if I have x squared and I take one x out of it, I'm left with 1x left over. Plus, and then I took the x out of my second term, 2x, so 2x becomes just 2. And if I were to take this term and distribute it back out, I know I'd go back to the original question that we had. So you can always check your work here. So in the first example, we just pulled out a number. In the second example, we pulled out a number and an x. And this is how we factor out the greatest common factor. Now looking at, well, what about when our first term doesn't actually divide the other two terms? Well, it's not a problem. We're just stuck with more fractions. So if I'm trying to pull a 2 out of the front of this, I'm looking at 2x squared, and then plus, and now I'm doing that fraction step like we did before. I have 7 divided by 2x plus, and then I have 3 divided by 2. So it's nicer when the thing you're pulling out actually divides each of the terms. If it doesn't, we can still do this. We just are stuck with fractions. So I pull a 2 to the front by dividing each term by 2. Now in the second one, I have a 3 that I want to divide by. So I pull a 3 to the front, and I'm left with x squared minus 5 over 3x minus 2 over 3. Oh, I didn't realize that was cut off the screen. So I pull a 3 to the front, and I'm left with an x squared. I subtract 5 divided by 3x, and then minus 2 divided by 3. So each of my terms gets divided by 3. So that's it for our examples for today. Please get some practice on simplifying the radicals here, on factoring out the greatest common divisor, and then factoring out when your greatest common divisor doesn't actually divide all the other terms. Give it some practice and reach out if you need any help.